All right, hi everyone. Hope you're having a great day so far. Today, I'm going to be continuing our CS50 walkthrough series, and we're going to talk about week 2 today. So let's go ahead and get right into it. So, starting off with a few things, we can see here in the CS50 webpage that this week is all about arrays and implementing code to use arrays, and it's pretty good. And here's the video right here. Definitely always recommend watching the video first before beginning any of the exercises. But yeah, we can go ahead and go to our first exercise, which is going to be Lab 2 Scrabble. So the goal of Scrabble is basically to calculate a score for an inputted word and then compare that to the score of a second player's inputted word and then output the winner of that word based on the Scrabble point system. So we can see down here that after getting all the necessary files from CS50, this score system right here is actually going to be implemented as an array, which I believe Professor Malin already made for us. But we're going to use that array to calculate the points of each player's word. So let's go ahead and get right into the code and see what that looks like. So let's go ahead and do that right now. Okay, perfect. So here is the Scrabble code. And some of this is the starter code, but most of this is going to be the code that I ended up using to solve this problem. So let's go ahead and start walking through this. So up here, as always, we have our libraries, the header file specifically, and then here we have the points array. And the order of the elements does matter in the array. So this is index 0. And then this is index 1, as we know, all the way to index 25 for the 26th element. So as we remember, arrays start indexing at 0 and not 1. So that's something worth keeping in mind for this exercise. And this one right here is a function prototype. So we can see that down here below, compute score function is actually defined, but up here it's just prototype, or we can say that this is a function declaration. So either of those work. Okay, cool. And then let's go ahead and go down here. So we can see that this is going to be the main function where the meat of things is happening. First things first, we want to get the words from each player. So player 1, we want their word to be using getString, and then we're going to prompt the user, hey, like, what is player 1's word? And then same for player 2. And then it's going to use the compute score function to compute a score for both words. And then we can see why we need to have the function prototype, because if we only leave the function definition down here, but don't refer to the function earlier, this main function won't work because it does need to know what compute score is. Since, as we know, the algorithm is read from top to bottom, we do need to have compute score at least mentioned before line 19. And yep, that's why we have this function declaration up there. Perfect. So now score 1 is going to record the score of word 1. Same with score 2. And then this conditional is going to compare the two scores. So if the scores are equal, then it'll print out tie. And then if the score 1 is greater than score 2, it'll say that player 1 wins, and then same with the player 2. And then we can keep heading down here. So I put a lot of comments, mainly because I wanted to really be clear about what's happening right here. So we can see that within the definition of the compute score function, we start by initializing a variable called score to 0. And then we calculate the length of the word. And then we iterate the score of each character over the length of the word. So what that means is basically we're going to loop over a word. So let's say our word is potato. We're just going to loop over each character. So P, then O, then T, A, T, O. And then for each of those characters, we're going to figure out what their score value is based on the array we have up here. So let me erase those. Wherever P is in this array, we want to assign that value to that. And since there's an A in potato, we know that A is going to have a value of 1, so that A is going to get 1 point, etc. Okay, cool. So what's happening here is basically the player might input, or the user might input, a string of uppercase or lowercase characters, or a combination of both. So we want to check whether each character is uppercase or lowercase. And the reason for that is because there are different ASCII values for uppercase and lowercase letters. So for example, uppercase A equals 65 and lowercase a equals 97. And then these just keep incrementing. So like uppercase B equals 66, lowercase b equals 98, etc. So what this is going to do is it's going to be like, okay, cool. We want score to update where score equals the previous score plus points word I minus 65. Let's say that the word we're looking at is apple. Well, what this is going to do is it's going to loop through the word, and for each character, it's going to ask, is that character uppercase or lowercase? So our first character is A, and A is uppercase, so we're going to go right here. And then what we're going to do is we're going to update score to the previous score plus points word I minus 65. So what does this mean? Points is the array of the Scrabble points, and then it's indexing into that array based on the value of word at index I minus 65. So in our word is apple, and word at index 0 equals capital A. So this is going to equal points A minus 65. And you might be wondering, okay, this is weird because we're going to subtract a integer from a character. But what's cool about C is that that's totally a natural thing to do in C. So as we mentioned earlier, in the ASCII, A capitalized does equal 65. So this is going to end up being the same as points 65 minus 65, and then that equals points at index 0. So all this is saying is it's going to take the previous score and add points 0, which if we scroll up, and let's keep in mind we're looking at points 0. So if we scroll up here, points at index 0 is 1. And that makes sense because since these are ordered in the order of the alphabet, and since we know that our first letter in the word apple is a capitalized A, it makes sense that the first letter in that word should get 1 point for the letter A. And that's perfect. So that's exactly what we want to see. So it's just going to add 1 point to score. And the same thing is going to be true no matter what letter it is. So let's say it's uppercase B. I won't run through the whole thing, but like I'll do the quick version. So B in ASCII equals 66 if it's capitalized. So this is going to be points, word 0, or word whatever, let's say wherever B is, it's just going to plug into B, which is 66 minus 65, and that's going to equal points 1, and that's perfect because points at index 1 is just going to be 3 points for the letter B. So that's exactly what we want. Excellent. So the same thing is going to hold for lowercase letters. It's just going to be a different subtracting value because, as we mentioned earlier, A equals 97, lowercase b equals 98, etc. All right, and then it's going to return the score, and that is going to be used here in the compute score function call for each player. Perfect. So that's Scrabble. We can go ahead and run it and just make sure everything looks good. So let's go ahead and do that. So yeah, so let's do apple, banana, player 1 wins. Excellent. Cool. But yeah, okay, cool. So ours is working great. So perfect. So let's go ahead and move on to readability. So just to recap on what needs to happen for problem set 2, we need to do readability and then one of these other 4. So I actually chose to do substitution, so we're going to walk through that in a second. Let's start with readability though. Okay, so for readability, I can exit Scrabble, and then I'll clear the terminal down here. Okay, so for readability, first we have all our header files, and then we have a few function prototypes. So the functions are actually defined down here as we saw earlier. So here's the count letters function, count words function, and count sentences function. And then in our main function, we have a few things going on right here. So we have, very first thing is going to be prompting the user to input text. And then for that text, we want to use the count letters function to count the number of letters. We want to use count words to count the number of words, and same with the sentences. And then the grade level is going to use the calculation that we saw in the specification for, what's it called? For readability. So let's go ahead and go to readability. Okay, cool. There we go. So for readability, grade level is calculated by this formula. This is the Coleman-Lau index. So the index of the grade level is equal to, according to this formula, 0.0588 times the L, where L is the number of letters, minus 0.296 times S, where S is the number of sentences, minus 15.8. Actually, I misspoke. Basically, L is the average number of letters per 100 words in the text, and S is the average number of sentences per 100 words in the text. Okay, cool. That makes sense. So that's why we have to calculate words as well. But yeah, getting back to our code. So yeah, these commented out things, I kept them in here because these were helpful for me to test whether each of the functions was actually working correctly. So if you want to test the functions as you write them, you can use similar notation. Cool. And then, yeah, so here's the implementation of the Coleman-Lau equation. Let me see. Yeah, that looks correct. Yeah, perfect. So There's a lot of parentheses here, but they just help to make sure that everything is going in the proper order of operations. So if grade level is less than 1, then it's going to print out before grade 1. Else, if the grade level is greater than or equal to 16, it's going to print grade is 16 or higher. Else, it's going to print the grade level. And this is because there's only 3 possibilities for whether it's going to be less than grade 1 over 16 or or a separate grade level. Okay, awesome. So this is the definition of count letters function. So we're going to start by initializing a variable called num letters to 0. And then we're going to count the length of the inputted word and then loop over that word. And then we're going to count the number of letters in that word. So whenever there's a letter, it's going to increment num letters, which starts at 0. And then it's going to return none letters. So the way we check for a letter is basically we can do is upper or is lower. There's a simpler way to do it too, which is just to do is alpha word I. So that actually works too, and that's simpler. So I would probably do that next time. But that's all good. So that works for that one. And then for count words, we want to start the number of words at 1. So since we're counting each space, this ends up working well for counting the number of words. Because if we start with 1 and then we add 1 for each space, then that's going to give us the correct number of words in this sentence, which is 5. Perfect. Okay, so let's go ahead and keep going along. All right, so this is count sentences. So similar as our other function definitions, what's happening here is we're going to initialize a value called num sentences to 0. And then we're going to have the inputted string be counted in terms of the length of the string, basically the number of characters. And then we're going to, same thing as before, loop over that string. And we're actually going to check for punctuation characters this time. So if there's a period, exclamation point, or question mark, then we want to increment the number of sentences in the input. And that'll give us the number of sentences, which is returned here. Perfect. And yeah, that's all going to be inputted into the main function. And that's going to be good to go for readability. So let me go ahead and just make sure that everything looks good and is running. Sweet. So it looks like everything works great and it's ready to go. So we can go ahead and move on to our final problems or practice problem of week 2, which is going to be, let me see, substitution. So for substitution, what we want to do is basically we want to input a specific cipher, and then we want to be able to input plain text and output ciphertext that uses the cipher to output that new encrypted text. So for example, let's say we want to input this string as our cipher, YTN, SHK, etc. Then that will convert hello into EHBBQ. And so we know that because, for example, E is in the standard alphabet, the 5th letter. And if we go here, 1, 2, 3, 4, 5, the 5th letter is going to be H. And that makes sense because here the E has been converted to H. Same with all the other characters. And so we want to be able to do that where any inputted string is going to work as long as it meets certain conditions. The cipher needs to fulfill 3 conditions. 1, has to have 26 characters. 2, has to be alphabetic. So basically it has to use the entire alphabet. And 3 has to be non-repeating. So you can't use a super short cipher like AXY. You can't use anything that repeats. And you can't use non-alphabetic ciphers or anything that contains non-alphabetic ciphers. Okay, cool. So let's go ahead and just take a look if there's any other things in the specification. So there are a few other details here, but they're all pretty self-explanatory. Essentially, the cipher is going to be inputted as a command line argument, or the key used for the substitution, I mean. Cool. And then it should print if there's any issues with the inputted key. Yeah, that's pretty much it though. So let's go ahead and start looking at the code for this one. All right, so let me go ahead and push this down a little bit. Okay, so here's my substitution. So, as always, we start with the headers we're going to use. And then here's the notation for starting off the main function. So it's going to take 2 command line arguments. So int argc, that basically means it wants a integer first, and then after that it can take an array of characters as a string. So let's say that someone inputted like 3 and then they inputted A, B, C. That would actually work for this first part, but we'll see later that it actually won't work for other parts. So let's go and move on down here. So as the comment notes, if there are more than 2 words or no input at all, then the main function should be stopped. So the way to write this out is if argc doesn't equal 2, then it'll print an error message. So yeah, if there aren't 2 command line arguments, it'll tell the user, hey, the correct usage is this right here. And then it'll return an error of 1. That's great because that's the first check, just to make sure, hey, there should actually just be 2 command line arguments. Okay, awesome. We're going to go ahead and move on to this next part. So what's going to happen here is that the length of the key is going to be calculated. So the way that's going to happen is it's going to do the Sterling function on argv1. So we might remember that argv0 is going to be the integer that's inputted first, and then argv1 is going to be the string that's inputted next. And these are the 2 elements that make up the command line arguments. So looking at this string key, we're going to basically compile all of argv1 into a string called key, and then we'll keep going. So if the key length is not equal to 27, then stop the function. So we want to remind the user, like, if there aren't 26 characters in general in the key, then like, hey user, the key should contain, or must contain, I mean, 26 alphabetic characters, and then return 1 as an error. But let's say that there are 26 characters. We want to evaluate if the key is entirely alphabetic or not. And I'll mention too, like, there's actually a few ways to do this in one step so that you don't need to have a sort of redundancy when you're checking, but that's okay. I was happy to do it over 2 steps. Stuff like this helps me sometimes to really understand what's happening step by step, even if there's a more elegant solution. But in best practice, it's generally better to aim for the most elegant solution. So that's something to keep in mind, that you can improve about your own code, which is awesome. Okay, so yeah, else else meaning that the key does have 26 characters, we're going to check for whether it's alphabetic. So in addition to checking whether it's alphabetic, I also checked for any duplicate characters. Because as we remember before, the 3 conditions for the key are 1, there must be 26 characters, 2, they have to be all alphabetic characters, and then 3, there can't be any repeating letters. So I initialized a integer variable called num alphabetic to 0, and then duplicate counter to 0. So duplicate counter is going to keep track of any repeating characters. So what's happening here is we set a for loop to loop over the length of the key, which we know has to be 26 at this point. And then if key at index I is alphabetic, then the integer variable num alphabetic is going to increment by 1. And then I also ended up using this print function just to make sure that num alphabetic was actually tracking correctly. And it was, which was great. And then now, as these comments note, this for loop is going to check whether there are any repeating characters. So it's going to loop over the cars in key after key I and comparing the ASCII value. So what on earth does that mean? Well, let's go ahead and scroll down and check it out. So this says for int j equals I plus 1 to j is less than key length minus I plus 1, j plus plus. All right, let's go ahead and assume that our key is going to be like a sort of interesting setup like this, like A, C, B, X, Z, etc., etc. And let's assume that this does use all 26 characters in the alphabet. So what's going to happen here for this first step in the for loop is if is upper key I and is upper key J, then key I is going to be compared to key J. And if they're the same, then duplicate counter is incremented by 1. So the reason J is this cryptic looking setup here is because basically I want to compare each letter at index I to every other letter starting at j equals I plus 1. So let's say I's right here. That means j is going to start right here at the next one over. And then it's going to loop across the whole rest of the key until j is less than key length minus I plus 1. Because if j ended at, or if this loop ended at j is less than key length, it would extend beyond the end of the key, but we don't want that. We want it to end right at the end of the key, which is going to, and this is going to allow us to do that, I plus k. So in this example, A is not identical to C, so duplicate counter is not incremented. A is not identical to B, so again, it's not incremented, not identical, not identical. So for none of these is duplicate counter going to be incremented. But if instead we had a setup like this, etc., etc., well, this is at index I, it's going to compare to B. And what's cool is this if else else else, and we'll see below there's one more, is great because not only is it going to be only compare capital A to capital A, it's going to be able to compare capital A to lowercase a. And that example is seen here. So is upper key I, if it's uppercase, which it is here, and is lower key J, meaning J is lowercase. So here we're going to go ahead and say this is J and it is lowercase. Well, if key I equals key J minus 32, then increment duplicate counter. So we might be wondering, okay, why the 32? Well, as we remember from earlier, capital A equals 65 on the ASCII chart, and then lowercase a equals 97 on the ASCII chart. So 97 minus 65 equals 32. So in this example, key at index I equals capital A, which is 65. And the question is, does that equal key J, which when J is right here, it's lowercase a. And as we saw here, lowercase a is 97. So 97 minus 32. So the question is, does 65 equal the result of that, which is 65? And yes, since it does, duplicate counter is going to be incremented by 1. So all that to say, these different conditionals are basically checking whether a character at index I is going to be the same character as another index, as every other index in the key, and that's going to repeat for every index I. That's great because we just want to make sure whether index I is uppercase or lowercase, we want this to work. And that ends up working pretty well. So those are all just going to run through that. So one other thing too is if there are 26 characters, but they're not all alphabetic, this else statement is going to print, hey, key must contain 26 alphabetic characters, which is perfect. And then finally for that part, this if statement is going to say, if either the number of alphabetic characters doesn't equal 26, or duplicate counter is greater than 0, meaning there's at least one duplication, then it's going to print this error message. Key must contain 26 non-repeating alphabetic characters. Perfect. And then if we do get to down here, then that's going to, let me see. Yeah, so if we do make it down here, then that means that there haven't been any error messages to exit the program. So we can continue moving along. That means that our key is valid. And given that the key is valid, we can start getting text from the user. So we want to get plain text as a string from the user. And then we want to get the length of that string text right here. And then we're going to print ciphertext. And the way that's going to happen is ciphertext as a string is going to get printed. And then we're going to print out each character of the ciphertext using this for loop. So let's go ahead and scroll down. Okay, so for int k equals 0, 2 k is less than plain text length, increment k. So what's happening here is we're checking if plain text k is upper, or if it's lower, or if it's a special character, because we want to leave special characters as is. Here, what's happening is we're converting uppercase letters in the plain text to corresponding uppercase ciphertext letters. What's happening here is we're calculating the sequence location in the alphabet of each character. So we're setting the sequence location as an integer to plain text k minus a. And then we're going to get the character of the cipher character to key at sequence location. And then finally, we're getting the final character as to upper cipher character. So cipher character might already be as an uppercase letter, but if it's not, we want it to get to upper, and then it's going to print that character, and then it's going to go back to the for loop and then keep going. So similar process for is lower. Yeah, so it's instead of using uppercase k, it's going to use lowercase, or rather, instead of using uppercase a, it's going to use lowercase a, and then go through the same process. And then instead of doing to upper, it's going to do to lower, just in case the cipher text at that location is not lowercase. Then it's going to print that character. And as I mentioned earlier, if there is a special character, then it's going to just print out that special character without doing anything else. And that'll work great. So let's go ahead and see it in action and just make sure everything's working okay. So CD, what's this one called? This one is Substitution. Cool. And let's go ahead and get an example from over here. Take substitution. So let's try a few things. Substitution without a key. Okay, so it's telling us, oh, we need a key. Let's put something weird. Key must contain 26 alphabetic characters. Okay, cool. So instead of doing that, let's go ahead and input one that we know will work from Professor Malin. Plain text, let's do hello Daniel, and then it's going to output excellent. That's my favorite word. All right, let's go ahead and go down here to check 50. Make sure everything looks good. Oh, yep, there we go. Okay, and while it's checking that, we can run style 50. Looks pretty good, excellent. And then while that's waiting, we can just reflect on all the things we've learned in this about arrays and ASCII, which is cool. Awesome, and I think we're pretty good. So let's go ahead and see what's up. But yeah, so it passed all the issues. And I'll actually mention, like, one thing that did trip me up at first was making sure that the function or the main function could take a key that has both uppercase and lowercase letters. So I think me fixing the code as I did ended up helping with that. But yeah, so that's all good to go. And we're set on that problem set. So we can double check, but yep, that's gonna be everything for problem set 2. And then if any of you would like me to review any of the other ones for problem set 2, like Wordle, Caesar, bulbs, let me know in the comments. I can totally take a look and get back to you on that. But yeah, thanks so much for watching. Hope that was valuable and helpful in some way, and hope to see you again soon. All right, bye.